Hello, this is Super CEO and welcome to video number 7. And today's question is, again, just one question because it's a huge one, as you can see later, and that is question 14. So this is the actual question. So it's again from Cambridge, question 14. The first part of the question here is the junior maths exercise where you have to plot the histogram and its corresponding polygon. And then the second part is now using that function, we're going to model the above situation with that particular function. And then basically at the end, we compare how effective it is to use this model, or maybe not that effective. So we're going to find that out. Okay, so now as usual, here's the statement that Cambridge textbook company wants me to put out for every video that I'm putting on internet. Okay, so now very first question of the 14. So see, that's the histogram and its related polygon. And part B is to show that it's relative frequency and polygon. And then, sorry, this is part B is where you have to show the area for the histogram and area under the polygon. So area of a histogram is all these sum of the areas of the rectangles. So, two of those shorter ones, which is this, and one taller one, which is that. So that gives you a 1 right there. And now the area under the polygon, so that's now this shape, sort of like triangle on top and then a trapezium. So, and that's exactly what I did. Is it half times 1 times 0.3? So that's 1 times, so okay, so what I've done is those two congruent triangles, and then this top triangle, and then that one there, the rectangle. So that's 2 times that triangle, so those two triangles. So if you like, that one and that one, those two, the same triangles, and then 2 times 0.3, so that rectangle. Okay, so here that's 4 and 2, so that's the width here is 2, and then the height is 0.3, so that's why it's 2 times 3, and that one half times 2 times 0.1, so that's triangle, so that's half times the base of 2, and the height there is only 0.1, so that's that. And also gives, so therefore when you sum up all those numbers, it also gives you 1. Okay, now part C is the cumulative histogram, and that's that one. Okay, so that, and at the very last point, it has to end up at 1. All right, now I'm going to explain what I mean by this in part D. Part D is where you have to work out all the quartiles. So to do that using the cumulative histogram, you know that it's better off to use this, going from end to end sort of polygon line rather than this midpoint. And midpoint is good when you have the usual histograms, class by class approach. But when you have a cumulative histogram, to draw the polygon properly, then you have to go from end to end point, not the midpoint. So that's what I mean by this one. Please, the second line or the violet line, if you can distinguish the color from your screen. Okay, so if you do that, to median point is half of that 0.5. Draw the line till you draw the horizontal line till you hit the actual polygon line and drop it down, and that's in the middle of 2.5 and 3.5. So that 3 is the median, and then the Q1 is half of half, if you like. That's 0.25, a quarter mark, which is about 2.25, and similarly 0.75 mark, the Q3 is that one. So this is around 3.75. Okay, so that's the summary. All right, now second part is the actual modeling using the frequency function. So that's the frequency function or little fx proposed. Okay, so then I did this because I want to keep the leading coefficient as, because it's negative. So that's x minus 1, 5 minus x. So I just reverse the order. That means I have to take the negative out. So that's why you have a negative there. Okay. So which means in part 1, if you get that expanded, why? Because later on I'm going to have to integrate to show that this is a PDF. Okay, so that, and remember the domain is from 1 to 5. So integrating from 1 to 5, then it's this, which is this one for the primitive function. And then that's now from that line to that line, that's the little trick that I described in the previous video. Okay, so drop the negative sign in the primitive and then swap the order so that you get that. So that I don't have to deal with the negative primitive. So substituting those two for evaluation, then you get this. And obviously from this point, you could have just used a calculator, but again, I didn't have a calculator, so I just did it manually. And you get 1, which means the first condition of the PDF is satisfied. And then the second one is to show that this little fx function is at least positive for that given domain. Well, we know that this function, which is up here, is a quadratic function with the negative leading coefficient. So that's what I mean by that. So it's concave down, at least in that domain between 1 and 5, which happen to be the two x-intercepts for that parabola. So which should look something like this. So at least in that domain between 1 and 5, it's a positive. So therefore, the second condition of the PDF is satisfied. Hence, this supposed or proposed little fx is actually a PDF. Now, part E. All right, so part E was now the drawing the model function on top of the histogram, which looks like this. Now here, that's the actual evaluation for the little fx for all these important x points. Okay, so then you will notice that f1 and f5 is actually 0, like that. f2 and 4, because they're symmetrical, and then they give a 0.28, which is just a shy of 0.3 mark in the actual histogram. So that's that one, just under 0.3, so that it's 0.28, and f of 3 is 0.0375, which is just under 0.4. So that's why it's shorter than that one. Okay, so that's the y equals fx curve. All right, now the next part is to find the cumulative function, or the CDF. So that's from 1 to x, not 5, x, and then all the x in the little f of x should be replaced by the t, and this is now dt, not dx. So as usual, evaluate it from 1 to x, and then little swap of the order of the evaluation so that I can drop the negative sign, and evaluating and do all that algebra. Okay, now here I've noticed that I can actually take 1 on 32 out, and you might say, what about the 3 as a common factor? You can, but I don't want to deal with all these fractions. So what I've done is, instead of taking 3 as a common factor, I've just multiplied it through, so that it's negative 1 on 32, and then this now takes the first 3 terms because I've taken the negative out, so that's now 3 and 3 cancel, so x cubed minus 9x squared plus 15x, and this one is now negative 1 because I remember I've taken the negative out, so it switches all the signs inside the bracket here. So that's going to be now negative 1 plus 9 and negative 15. Okay, so collect the like terms, then you get this. And believe it or not, that's your big f of x. And part 4, this is where you now have to compare. So previously, remember, using the actual histogram, we found that the quartiles were, that's the lower quartile 2.25, median, and upper quartile being 3.75. Now let's see how effective our model is. Well, if you substitute 2.25 into that, you actually get 0.23 rather than 0.25. Okay, when you substitute x equals 3 into that function, then you get 0.5. That's exactly the same, because if you have a look at this, that's 3 is right in the middle. Of course, that doesn't depict the actual big f of x, that's the little f of x. So that means f of 3 here means from the area under the curve from 1 to 3. So that's the area. And as you can see, that's exactly half of the entire area of that concave down parabola. So you would expect that that's going to be this 0.5 mark. All right, and 0.35, sorry, x equals 3.75 substituted into that function, then you get 0.768 compared to that. So that's that one. Now, and so what do you reckon? I reckon this is not too bad. Depending on how you look at it, that's only 0.02 difference. That's, that's, yeah, 0.018 or 0.02 sort of difference. So I reckon this is not a bad approximation. So that's my conclusion. And that about does it for this video. And I hope this video helped you complete this question. And I'll see you guys next time.